Hello students, welcome back to the class. Today we will see NCERT chapter 2 structure of atom exemplar questions. So there is an announcement regarding a mock test. So it will be held on 24th. So this coming 24th, day after tomorrow. So please attend that mock test so that you can get an idea how your preparation is going on. So it will be covering all the topics that I have taught you till now. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So here is your first question. So question is saying that which of the following conclusions could not be derived from the Rutherford's alpha scattering particle scattering experiment? Options are: most of the space in the atom is empty. Second is the radius of the atom is about 10 to the power minus 10 meter, while that of nucleus is 10 to the power minus 15 meter. Electron move around in a circular path of fixed energy called orbits. Electrons and nucleus are held together by electrostatic force of attraction. So I would suggest you to write the correct answer by yourself. Your time to solve this question starts now. Okay. So the time is up. What was the Rutherford's alpha scattering experiment? Remember, he radiated the gold foil with alpha particle and then he received the outcome with the help of a zinc sulfide panel. Okay. So there were conclusions of this Rutherford alpha scattering experiment. On the basis of that, he gave some postulates of his atomic model. So you have to identify that which postulate is not derived from his experiment. The correct answer will be 3. So he was not describing any energy about the electron. Okay. So he was telling that electrons are revolving around the nucleus, but he didn't talk of a fixed path of or a fixed energy. So this was there in the Bohr's model. So what would be the solution for this question? If I try to explain it, then the idea of the circular path with a fixed energy was put forward by Bohr, as I told you, and it was never derived from the Rutherford's scattering experiment. Okay, so out of this large number of circular orbits theoretically possible around the nucleus, the electron revolves only in those orbits where the energy of value is fixed. Value of energy is fixed. So you have learnt about it. It is called as the stationary state or the energy levels. Now, what about the options that we didn't choose? So these remaining options have a statement that is according to the Rutherford's alpha scattering experiment. So this was one of the statement that most of the space in the atom is empty. Yes, he said that because most of the particle went through the gold foil without any deflection. So it was clear that inside the gold foil atom there is very much space that is empty, and due to that the alpha particles were passing easily through them. Now next, this was also in his model in which he was describing the radius of the atom which is about 10 to the power minus 10 meter in the order of angstrom. Okay, while that of the nucleus was 10 to the power minus 15 meter. And the third one was the electron and nucleus are held together by the electrostatic force of attraction. Now this conclusion was also derived from the Rutherford experiment, and the deflection pattern of the alpha particle indicated that there is a positively charged nucleus and there are negatively charged electrons, and those are held together by the electrostatic force of attraction. I guess this question is clear to you. Moving on to the next question. So the next question is regarding the probability density plots of 1s and 2s. So I will suggest all of you to write the answer by yourself. The question is saying that the probability density plot of 1s and 2s orbital are given in these plots. So these are the two plots. You have already seen it. It is of 1s and 2s. Now the density of the dots in a region represents the probability density of finding the electron in the region. Now on the basis of this diagram, you have to select that which of the following statement is incorrect. Okay, remember you have to find the incorrect statement, not the correct one. First option is 1s and 2s orbital are spherical in shape. So this is the first statement. Second is the probability of finding the electron is maximum near the nucleus. Okay. Next is the probability of finding the electron at a given distance is equal in all direction. Fourth one is the probability density of electrons for 2s orbital decreases uniformly as distance from the nucleus increases. So what will be the correct answer? Any guesses? Your time to solve this question starts now. So this is a very good question because it is touching the concept of this probability density and kind of looking at its complexity, right? So any guesses for this question? You can just write it by yourself. So what will be the correct answer? The correct answer will be that the probability density for 2s orbital decreases uniformly as the distance from the nucleus increases. Now this statement is wrong. Why it is wrong? For that you have to look back at the plot that you got. Okay, so there was a plot for 1s and 2s. Was it uniform? No, it was not uniform at all. So what we can write in the solution part? So as we move for 1s orbital, the probability density is maximum at the nucleus. Okay, and then it decreases very sharply as we move away from it. Okay, very good. But what about the 2s orbital? If you look at this graph here, then you can see a region that is having a lighter portion in the middle. So it is first increasing, then it is decreasing in this middle part, and again it is increasing, and then it goes on decreasing. So this region is not uniform, but in case of 1s, it is completely uniformly decreasing. There is no radial node. So due to the presence of the radial node in the 2s orbital, there is a non-uniform decrease in, or you can say a non-uniform change in the electron density. Is it clear to all of you? Any doubt in this question? Okay, let us move forward. Now next question, the number of radial nodes for 3p orbital is. So there are 4 options, 3, 4, 2 and 1. What will be the correct answer? You have some time to solve it. Your time starts now. So what will be the number of radial node in this question? Okay, very good. So let's see. What is the formula for calculating the radial node? You have to remember that because that is important. So the correct option is first of all 1. There will be one radial node. How we will solve it? So to solve this, you must know first of all the formula as I told earlier, and second the value of L and S for this given orbital. So this is your formula, n minus L minus 1. Okay. Then here n is your principal quantum number, L is your azimuthal quantum number. If you take 3p orbital, then in 3p orbital the value of the principal quantum number will be 3. Okay, n is equals to 3, it is the shell. Now what about the L value? So for p orbital it is 1, we know it. For s orbital it is 0, p orbital it is 1, d it is 2, and so on. Now put this values here in the given formula. You will get your number of radial node as 1. Okay. Moving on to the next question. So this is about angular nodes for the 4d orbital. So let me explain what is angular node and radial node. Before that, if you are getting confused in that. So suppose you are taking a s orbital. Okay, you are taking a s orbital, or suppose if I take p orbital, right? So p orbital will look like this. Okay, is this the shape of p orbital? Yes, this is the shape of p orbital. Now, if I do not draw the boundary surface diagram, instead I try to draw the probability density. Okay, just dot it everywhere. Okay, so there is a dot type of function. You must have seen this is the NCERT, and I have already explained this. Now this diagram is true for 2p. Okay, what about the number of nodes here? The formula for number of nodes is always n minus 1. So take n is equals to 2. For 2p it will be 2 minus 1. So the total number of nodes present in 2p will be 1. Now there is only one node, and that node is angular node. Okay, that node is angular node. Where it is present? If I ask you, where is the angular node present? It is present here in the between. So you can see very clearly that the electron density is decreasing, and in the between it is 0 because there are no dots present in the middle. Okay, so this is your angular node. Is it clear to all of you? What is angular node? Any doubt in this? Now the number of angular node is always equals to the value of L. So what is the value of L for p orbital? What is the value of L for p orbital? Anyone? Okay, so it is 1. So remember that for p orbital, the number of angular node will be always 1, which is present in the middle. Now, what is the count of radial node here? If I ask you that what is the count of radial node, what it will be? So here it is 1, which is equals to the value of L. Then if I ask you about the radial node, so what will be the number of radial node in the p orbital? 2p in the 2p? Yes, it will be 0. Very good. Okay. Now let us take the example of 3p. What I am taking? I am taking now 3p. So if you take 3p, you will observe that there are dots present everywhere. Okay, there are dots present everywhere except a patch. Okay, so you can see that there is a patch here. So this is the patch where your electron density is going 0. So this is for what? This is for 3p. Okay, so what is the number of nodes in this case, if you apply the formula of n minus 1 for 3p, what will be the number of nodes? Total number of nodes? It will be 2. Very good. N minus 1, that is 3 minus 1 is equals to 2. Now, what is the number of angular node? What is the number of angular node in this case? It will be 1. Okay. Very good. So that is simply equals to the value of L. So for every p orbital, the angular node will be always 1. Now, if I ask you what is the number of radial node, what will be your answer? Okay, yes, it will be 1. And where it is present? So this is your angular node. Sorry, this is your radial node that I am talking about. So it is basically a space in between the orbital where the electron density becomes 0. Got it? Now, is it clear what is difference between radial node and angular node? So radial node is again present here only in the middle. This is called as the nodal plane. Nodal plane, and this indicates your angular node. Any doubt in this? Is it clear to all of you that what is the difference between angular node and radial node? So it's very simple. Just use the formula of n minus L minus 1. Okay, to find the count of angular node, n minus L minus 1. So the value of n is 3. The value of L is 1. Minus 1, you will get it as 1. Now moving on to our next question. I guess this thing is clear to all of you. So here in this question, you have to count the number of angular nodes for the 4d orbital. So how you will count it? We will apply the formula simply. So you have some time to solve this question. Your time starts now. Okay, so 3 seconds more. What will be the correct answer? I guess it's an easy one to solve. The correct answer will be 2. So there will be 2 angular nodes. Okay. Remember students, you are counting the number of angular nodes. So what is the value of angular nodes? It is always equals to the value of L. So for the d orbital, the value of L is 2. Therefore, the number of angular node is 2. Okay, if you are not able to solve it, no problem. It's very easy to understand, right? So once you remember that the number of angular nodes for any orbital is simply equals to the value of L, you will be easily able to solve it. So that same thing is applied here. Number of angular nodes is equals to L, which is L is the azimuthal quantum number. And for 4d orbital, the value of L is 2. Therefore, the number of angular nodes is also 2. I guess it is clear to all of you. Any doubt in this question? Now, moving on further. Yes, Sanchita, what is your doubt? So, so you didn't understand the whole point? Is it so? Yes, we use the value of D. So for D, the value of L is 2, I guess. So therefore, we are taking the angular nodes as 2. Now moving on to the next question. Next question, for the electrons of oxygen atom, which of the following statements is correct? Your options are A, Z effective for an electron in a 2s orbital is same as the Z effective for an electron in a 2p orbital. Second one, an electron in the 2s orbital has the same energy as the electron in the 2p orbital. Third option, Z effective of an electron in 1s orbital is same as the Z effective of an electron in 2s orbital. Then the fourth one, the two electrons present in the 2s orbital have a spin quantum number ms but of opposite spin sign. So it's a very good question. Your time to solve this question starts now. So if you know it, you know it because it's a theoretical question. So let us see what is correct. The correct statement will be the fourth one. Okay. So it is easy to find the correct statement in this question rather than buzzing around other options. So you know it very well that in a given orbital, if there are two electrons, they will always have the opposite sign. Okay, so that thing is written here. So therefore, this statement is correct. You know it very well. If you are filling a orbital, then in that case you will fill them in the way that they have the opposite signs. Okay, if they're in the same orbital, you have to fill them in the way that they have the opposite sign. If one is plus half, the second will be minus half, and the vice versa is also true. Now, how we will look onto the other statement, that is important. Okay, before that, let us look at the correct one. So one will have plus half and the other will have minus half. Therefore, both will have different spin. Now we'll deal with each and every statement one by one. If you have a doubt, please ask it. So first is, the electron in 2s and 2p orbitals have different screening effects. Okay, and due to this reason, the Z effective is different for 2s and 2p. In fact, the value of Z effective for 2s is greater than the value of Z effective for 2p. Therefore, the first statement is wrong. Did you get my point? So we have studied in the previous class that the penetration effect, remember the penetration effect? So the penetration effect of S is greater than the penetration effect of P. As a result of that, so penetration means how deeper the electron is going. Now, as a result of greater penetration effect of the S orbital, it will remain closer to the nucleus, and hence this Z effective, which is simply the force that is applied onto the orbital, increases because of its closer vicinity. Is this point clear to all of you? Now moving on to the next point. So it was given that the energy of 2s and 2p orbital is same. Now this is also incorrect, because if your 2s orbital is experiencing more Z effective, or you can say it is experiencing more attractive force, therefore its energy will decrease. As a result, the energy of 2s orbital will be lower than the energy of 2p orbital. Their energy can never be same. Now we have also seen this thing also, that if you are given the same principal quantum number, then in that given quantum number, the energy of orbital increases in the way that S has the lowest energy, then comes your P, then D, and then F. So these questions are all from the filling up of orbital, which is section 2.6.3 from NCERT. What was the last statement? That the Z effective of 1s orbital and 2s orbital are equal. Okay, so this was the last statement. So again, 1s, and if you compare 1s and 2s, 1s is a orbital that is present in the first principal quantum number. Now you know it very well that as we go on increasing the value of principal quantum number, which is here increasing from 1 to 2, its size increases. So if the size of the orbit is increasing, the size of its orbital will also increase. Okay, and hence the Z effective for 1s will be always greater as compared to the Z effective of 2s. Now you can think it of in other way also, that since your 1s is coming first, or just after the nucleus you have the 1s, and after that you have the 2s. So 1s is coming first, so it will experience a direct force from the nucleus, whereas the 2s is present behind it, so there will be a shielding effect. The 1s will shield the 2s, and as a result it will experience a less force. So we can say that Z effective of 1s is greater than the Z effective of 2s. So if you have a doubt, you can ask it right now before I move to the next question without any hesitation. Anyone has a doubt in this question? So there is very much theoretical to consider here. Okay, there is very much. Okay. So which point are you facing difficulty? In which point are you facing difficulty? Okay, so third point. So have you watched the previous lecture? So if you have watched the previous lecture, I have written there that if you are talking about the energy of orbital in the same orbit, then it was written there that S has the lowest energy, then the P, then the D, and then the F. Now it was written in the option that 2s and 2p have the same energy, but according to this order, and since we are considering oxygen atom, which is a multi-electron system where the energy of each orbital is not same and where the energy increases in this order, therefore the energy of 2s will be less than 2p. Do you remember this thing? Any doubt in this part? Is it clear now, Piyush? So anyone else who has a doubt in this question? Okay. Now let us move forward. Next is, if traveling at same speeds, which of the following matter wave have the shortest wavelength? Okay, so you have to look upon the wavelength. Remember, this is from the de Broglie part. Your four options are there: electron, alpha particle, which is simply helium 2 plus particle. We have already talked about it. Then comes the neutron, and lastly comes the proton. So what will be the correct answer? Just write it by yourself. The time to solve this question starts now. Remember the de Broglie relation between the wavelength and the mass. Okay, your time is up. Let us see. So the correct answer will be alpha particle. Very good. It will be alpha particle, which is option number 2. Now how we will solve it? We know it from the de Broglie equation that lambda is equals to h by mb. Now we can clearly see that lambda is inversely proportional to the mass. Now if I ask you that which has the least mass of all, then what will be your answer? Or which one will have the greatest wavelength? So I am leaving this question on to you. Then if you compare all of this, then the electron, yes, the electron will have the smallest mass and it will have the greatest wavelength. Then comes your proton, okay, and proton and neutron are having approximately same mass, so they will have approximately same wavelength. And lastly comes your alpha particle, which has the mass of 2 proton and 1 electron. Now we can neglect electron, so we can say that it has a mass of 2 proton. So clearly it will have a what? It will have a smaller wavelength. So this is directly coming from the relation that lambda is inversely proportional to 1 by m. And as a result, since your h is constant, okay, and it is also given that they are traveling at the same speed, so velocity is also constant. Therefore, the helium 2 plus, which has the highest mass, it will have the shortest wavelength. And also remember that the electron has the least mass, so it will have the greatest wavelength or the longest wavelength. Our next question. Arrange S, P and D subshell of a shell in the increasing order of effective nuclear charge experienced by the electron in them. So this is our objective type. How you will rearrange it? Just write it in the copy by yourself. Now you have some time to write it. What you have to do, you have to arrange the SPD subshell in the increasing order of effective nuclear charge. So this is a short answer type question from NCERT Exemplar. Okay. So let us see what is the correct answer. So it will be in the one line. So we know it very well that S orbital is spherical in shape. Okay, so here we are talking about the effective nuclear charge, right? We are not talking about the energy. You have to say that which one will experience the greatest nuclear charge. I've already told you. We have to consider S, P, D and F. Okay. Now, we know it very well that your S orbital is closest to the nucleus. Okay, and as a result, it will experience the maximum effective nuclear charge. So I guess you are confused about the energy and effective nuclear charge. So if your energy was decreasing, means S orbital was having the least energy, it means it was experiencing the greatest force. I am again repeating the very important statement that since your S orbital is having the least energy, it means it was experiencing the greatest attraction force due to the effective nuclear charge, and as a result its energy was decreasing. So if I say this, then we can write the order as greatest for S, then comes your P, and lastly comes your D. Any doubt in this? If you have a doubt, you can ask. So I guess some of you got it wrong. Is it clear now? For those who have got it wrong. Okay. So let me repeat that statement. So first of all, I already told about the penetration effect. So listen it very carefully. I am repeating it once again. This point is very difficult to understand for most of the student. So if you are facing difficulty, no problem in that. So if I talk about the penetration effect, so first of all, you have to understand what is penetration. Penetration means to get closer to something. Okay. So you can simply tell it closer. So always remember the S orbital will be closer, then your P, then your D, and then your F. Remember, this is for the same orbit, means all of this should be in the same orbit, then this order will be followed. So if I am taking the 5S, then you have to take the 5P also, 5D also, and 5F also. If you are taking one as 5S and one as 4P, then it will be wrong. Okay, so this is always for the same orbit. Is this point clear? The first is the penetration effect, means S orbital is present at a closer distance. Now, what I am telling? I am telling that Z effective is also higher for S, then P, then D, then F. I have already explained this. What is Z effective? I am telling it once again. So it is basically the force of attraction. Okay, it is the force of attraction. And which type of force? It is electrostatic force, because it is present between two different type of, or you would say opposite charges, not different, two opposite charges. Now since if your S orbital is closer, that means distance is less for S orbital, and as a result it will experience a greater force. Now I guess this point is clear, and similarly the lower will be the P, then comes your D, and lastly comes your F. Any doubt now? Anyone who has a doubt in this part? Okay. Now, if this attraction force is higher, so I am throughout the statement I am saying that if your attraction force is higher, that means your energy will be lower. Okay, so therefore S has the lowest energy, then the P, and then the D, and then the F. But students, remember this is for the same orbital always, same orbit always. And also it is true for only multi-electron system, where we have more than one electron. Okay, it is not true for hydrogen-like species. Now moving on forward to the next question. In the next question, you have to see that according to the de Broglie, matter should exhibit dual behavior, that is both particle and wave-like property. However, a cricket ball of mass 100 gram does not move like a wave. Okay, so when it is thrown by a bowler at a speed of 100 km per hour, calculate the wavelength of the ball and explain why it doesn't show wave nature. So just first of all calculate the wavelength related to this ball, and then we will see that why it is not relevant for the ball. Your time to solve this question starts now. The time is up. Okay. Yes, due to the huge mass. We will see what is the correct answer. So first of all, it is given in the question that mass is 100 gram. So we are converting it in the SI unit. We will write it as 0.1 kg. Second thing is the conversion of velocity into standard unit. So to convert kilometer into meter, we multiply it by 1000, and to convert hour, we multiply to the minute, to the second, we multiply it twice by the 60. Okay, any doubt in this? Why are we multiplying this? Because 1 hour is in the denominator. So to convert this thing into seconds, we have to multiply twice with the 60. Now, if I calculate this, you will get it as 1000 by 36 meter per second. So if you put all these values of mass and velocity of the ball in the de Broglie equation, which is lambda is equals to h by mv, you will get your wavelength as 238.5 into 10 to the power minus 36 meter. Okay. Now you can see very clearly that this wavelength is very small. Okay. And as a result of this, the wave nature of this cannot be detected. So this is all about the NCERT Exemplar. So now we will solve a DPP regarding a topic. If you have a doubt, you can meanwhile post it in the chat section. So I am opening the DPP, just wait for a while. So this is a DPP related to the Bohr's model. Okay. This is a DPP related to the Bohr's model. According to the Bohr's model of hydrogen atom, the radius of the nth orbit is given by according to the Bohr's model, you have to calculate the radius of the nth orbital. So what will be the correct answer for this? Any guesses? What will be the correct formula? So you have to look for the formula, right? For the Bohr, for the hydrogen atom. No, it will not be 3. So the formula is written in this way. If I talk about the radius, it is equals to R is equals to n square A naught. So this is the formula. Now there is a term for the atomic number also. So what will be the total formula if you consider the atomic number also for the radius of the nth orbit? So it is R is equals to n square A naught by Z. Okay. It is n square by Z. So this is the total formula for the radius of the nth orbit, which is R is equals to n square A naught by Z, isn't it? Now, for the case of hydrogen atom, this Z will be taken as 1. Therefore, your formula will be R is equals to n square A naught. Is it clear? Now, what is the value of A naught? Anyone? What is the value of A naught in this? In terms of angstrom, what is the value of the A naught? Or you can write it in meters also if you want. Any guesses? So it is basically 0.529 angstrom, okay, or 552.9 picometer. Very good. So this is the value of your A naught, and it is always constant. Now moving on to the next question. In this question, you have to calculate the energy of the electron in the nth orbital. So you have to directly look for the formula. Again, I guess it's an easy one. So what will be the energy for hydrogen-like atom? So it will be minus 2.18 into 10 to the power minus 18 Z square by N square. Yes, the correct answer is 1. Now second question from my side is that what will be the corresponding electron volt formula if I want to calculate this energy in the electron volt form? What we will write in place of this 2.18 into 10 to the power minus 18 for the electron volt option? It will be 13.6. Very good. It will be 13.6 electron volt N square by Z. What is N here? What is N here? Anyone? N is the, which quantum number is N? It is the principal quantum number, and Z is the atomic number. Okay. Now moving on to the next question. So this is your formula in case of electron volt. If you write a formula in terms of electron volt. Our next question, which transition in a hydrogen atom emits a photon with the longest wavelength? Out of this, which will emit the longest wavelength? How we will solve it? So for that, you should remember that the relation between energy and wavelength is having a inverse one. So if the energy is maximum, or you can say if the energy distance is maximum between the two shells, then the wavelength will be minimum, and the opposite is true. Now we have to look for the longest wavelength, that is for the shortest distance. So it will be option number 4. Very good. It will be option number 4. Moving on to the next question. Here we have to see the angular momentum of an electron in the nth orbital of a hydrogen atom is given by. So we have to look for what is MVR is equals to. So the correct answer will be, it's very simple, N. Now what are the values of N that we can take? So just write it in the section that what are the values of N that we can take. Can we take it 0? Is it possible? No, we can never take it 0, or else it will be a case of collapse of the atom. So we can write. So I guess someone has a doubt. Let us see. So he is saying that why not 1 in previous question? Okay, so that's a good one. So that's a very good question to ask, Naman. So there is a very interesting point in this. So everyone listen it very carefully. So I guess most of you don't know about it. So if you see the first orbit, it is n equals to 1. Okay. Then comes n equals to 2. Then comes n is equals to 3. Okay. Then comes n is equals to 4. Then comes your 5. Now what can you observe in my drawing here? So first of all, what can you observe in my drawing? Do you see any change? On moving from n is equals to 1, yes, the distance is decreasing. So basically, I am representing it with the help of the distance. Here, the energy difference is decreasing. So remember, as we move away and away from the nucleus, the distance between, or you can say the energy distance, energy gap between the orbitals gets decreased. Okay, so the difference between 3 and 2 will be the least, and the difference between 5 and 6 will be the distance between 3 and 2 will be more as compared to the distance between 6 and 5. Is it clear to all of you? Because in both cases, the delta n is 1 because there is only one unit change. But since as we move away from the nucleus, the energy gap between the shells goes on decreasing. Is it clear? Any doubt now? Yeah. Now moving on to the next one. So we have already solved it. It will be equals to mvr is equals to nh by 2 pi. Now again, is this value of n equals to the principal Compton number? Yes, it equals to the principal Compton number, this n. Now last question. In this one, which statement about Bohr's model is incorrect? So there are 4 statements that are given. First is electrons move in circular orbits with quantized angular momentum. Second is the energy of orbits decrease with increasing n. Third is electrons emit energy when transitioning to higher orbit. And fourth is the model fails to explain the Zeeman effect. So I have not talked about Zeeman effect, but still you can observe that which is incorrect. So what will happen if there is a transition to a higher orbital? If it is not emitting energy, then what it will do instead of that? It must absorb. Okay, it must absorb energy, not emit. So this was all for today's class. I hope you enjoyed the lecture. Now in few minutes our maths faculty will come here and join you. Just wait for a while. Meanwhile, if you have a doubt, you can ask. Anyone who has a doubt in any part? So let us see the result. Okay, so we have done it all correct. Okay, so anyone has a doubt, please explain the last question. So I will make you explain the Zeeman effect right now because we have some time, I guess. So it will not come in the exam, hopefully. If it comes, let's see. So basically there are 2 types of effect. Okay, so before explaining this, let me explain the last question properly because that is important for the exam point of view. So yes, if you are transitioning from a lower orbital to a higher orbital, means you are moving up in the energy. Okay, so suppose you have to go from a plain area to a hilly area. For that, you have to understand that you require energy for that. Okay, you will never emit energy, and as a result, this statement is wrong. So it will absorb energy always. So okay, so just wait for a while. Our maths faculty will join you. So we are lacking time. Hopefully we'll see this topic in the next lecture about Zeeman and star effect. So star effect is basically the splitting of electrical lines in the splitting of atomic orbital in the presence of electrical field, and Zeeman is in the presence of magnetic field. So thank you for attending the lecture.